Hey, good to have you back, Logan, for another installment of Math from Your Couch. Today, what I'd like to do is take a look at what happens when you have two chords intersecting each other. In the last video, what we did is we looked at what happens when you have what happens with their angles. So, what are the angles that occur? From here on out, for the next three videos, what I'd like to do is focus primarily on the segments. So, how long each of those pieces are. So, in this picture, what we have is we have two chords that are intersecting each other at point E. All right, so they're intersecting each other at point E. Now, when they intersect each other, what you'll notice is that the chords break each other up into four pieces. And this leads to our first property. The property essentially says that if you were to take chord AB and multiply the pieces of that chord, it should equal the multiplication of the pieces of chord CD. The products of the pieces of the intersected chords are going to be equal. Now, this is a lot of words, so what we want to do is we want to break it down. So let's color code some things here. So I'm going to take chord A, B, and I'm going to break it up into the green chord and the red chord, AE and EB. And then I'm going to do the same exact thing with chord CD. So chord CD is going to break up to the blue and the yellow chords, CE and ED. Now, based on the property that's written above, you'll notice that the products of those pieces, so if I was to multiply the red chord and the green chord, it will equal the blue chord times the yellow chord, or AE times EB, right? So those pieces make chord AB. If I multiply them, I will get the multiplication or the product of CE and ED. All right, so let's jump into an example and let's take a look at how this is going to work in an actual problem. So what we have here is we have example number one. We need to find out what x is. I've gone ahead and color coordinated it, but in the homework and in other problems you're going to see, you're not going to see them color coded. So you'll notice that chord here is 16 and the chord here is 6x. The biggest mistake, or 6 and x, the biggest mistake that people will do is they'll say, oh, well, x has to be 10. I need you guys to clear that out of your head. I'm not saying that the chords are the same. I'm saying that the products of their pieces are the same. So if I was to take the green piece, right, so the part of the whole 4 and 12, the green piece, and multiply it to the red piece, that is what needs to equal. Not their sums, but their products. So now I'm going to multiply the 6 and the x. We're going to go 6 times x. And then we just simplify this problem out. 4 times 12 comes out to 48. 6 and x is just 6x. Isolating the x, we're going to divide both sides by 6. And we get that x is equal to 4. Sorry, x is equal to 8. My mistake. So we have our other piece, this piece right here. And if you go back, you'll notice 6 times 8 is 48, 4 times 12 is 48, and that's exactly what this theorem was stating. All right, so this is our easy problem. This is going to be essentially what I'm going to be testing you on. Do you know how to do this? Do you understand the concept? But I want to advance the concept just a little bit more, and I also want to start looking at some other more complex problems. So example number 2, what is x? So this problem, we're going to work it out the same exact way. I got rid of the color coding, so now you want to think about what's going to be multiplied together. Also, I also just want to remind you that this type of problem is actually getting you guys ready for Algebra 2. So in a few in a few months, you're going to start going into Algebra 2 classes, and you're going to need to remember a couple of concepts, and this is probably one of the most important concepts to know on day one. All right, so let's go ahead and multiply this thing out. So we know that we're going to multiply the 2x and the 3. So we're going to say 2x times 3 is equal to, so this one and this one, and then we're going to multiply the x minus 1 and the x plus 6. So it's going to be x minus 1 times x plus 6. Now the first thing I want to say is this, is that since these are monomials, parentheses are not a necessity. But once you have addition and subtraction being multiplied together like that, you're going to want to make sure that you put parentheses around that. Now, if that right there kind of gets something going in your gut, like you have an instinct there, then that's good, because this is what we're going to do. To multiply this, we're going to want to FOIL this out. Over here, this is just straight multiplication, 6x. But on the other side, on the right side, you're going to have to FOIL that. That means you're going to multiply the f, the first numbers, right? So this is just review. F stands for the first group of numbers, the numbers in the front of both groups. So we're going to have x to the power of 2. Next, the O in FOIL. The O stands for the outside. So the outside of both groups. So x is on the outside and 6 is on the outside. This is going to give us 6x. Next, the I in FOIL stands for the inside, the inner terms. The negative 1 and the x, which gives us, 6 times x was 6x. The negative 1 and the x is going to give us negative 1x. but some people just write negative x. And then the L of FOIL stands for the last terms of each group. So that's negative 1 times 6, which is negative 6. All right, so this is more Algebra 2 review, or preview, is that you're going to need to know how to solve something that looks like this. Now, the moment you get an x squared in there, you have what we call a quadratic. All I need you to remember is anytime the exponent occurs, you're going to want to not set it, you're going to want to set it to 0. All right, so we're going to collect like terms here. That's going to give us 5x and then minus 6. Unfortunately, it's not equal to 0, so I want to get rid of this thing right here. So I'm going to take away, I'm going to get rid of that 6x. Rather than subtracting here, because they're not like terms, I'm going to subtract it from this one. Now, if it didn't match any of them, I would just throw it at the end, or throw it in the front, or throw it in the middle. I just put it somewhere else. So we have 0 equals x to the power of 2 minus x minus 6. All right, next, once you have a quadratic and it's set to 0, there are multiple ways you can solve it. I want to focus on factoring. So the next thing we're going to do is we're going to go ahead and factor this problem. So this is the factoring portion. Now factoring means you need to think of things that can multiply factors of 6. I can think of 2, 6 and 1, and 3 and 2. The second thing you need to do for factoring is focus on the front part. I can only think of one thing you can multiply for x squared, and that's x times x, at least anything of any use to me. The last thing you're going to do is you're going to see if these numbers work. Now, since this is a minus sign, you're going to subtract these numbers to get the middle. If this was a plus sign, then you would add the numbers to get the middle. You'll notice that since it's a minus sign, 6 minus 1 is 5, which is not the middle. But if I take 3 and 2 and subtract them, I get negative. I can get a 1, a negative 1. So that's what I'm going to do. So I'm going to break it down to x in the front, right? So the f of FOIL, so x and x is the front. And then the 3 and the 2 is going to give me the last terms. Now to get the O and the I, the outside and the inner terms are going to be multiplied here. And you'll notice to get a negative x, we need to have a negative 3x, and a positive 2x. And that's how they're going to subtract. Now remember, it's still equal to 0. So once we have that, we can set it into two different equations. Our first equation can be x minus 3, our first factor equal to 0, and x plus 2, our second factor equal to 0. We add 3 to both sides of our equation, and we get x is equal to 3. We subtract 2 from both sides of our equation, and we get x is equal to negative 2. Now, we have two possible answers here, but those are our algebraic answers. What we want to do now is find out which of these makes sense geometrically. So we're going to take our answers and plug them back in. So I'm going to take the 3, and when I plug in a 3, I get a 6 and a 3. And when I take the 3 and plug in here, I get a 9 and a 2. And you'll notice 2 times 9 is 18, 6 times 3 is also 18, and those numbers make sense. Now I'm going to check with the negative 2. So I take the negative 2 and I put it in there, and I get a negative 4, and right away I'm going to stop. The moment I get something that doesn't make sense, this segment is equal to negative 4 length, makes no sense, means it's not an answer. So we're going to take this guy right here, and we're going to cancel it out. Our only solution is x equals 3. All right, if you have any questions, please come by class. Remember, the first example is primarily what I need you to understand, but since we are getting ready for Algebra 2, you're going to see some examples that look like number 2. So be prepared. If you have questions, come by tutoring, come by class hours, or send me an email or hit me up on Google Classroom. Wish you guys the best of luck, and I'll talk to you soon.